Yeah, hi, good morning. Uh, Thanks for joining the session of the first session of Azure Data Engineering. And I hope every one of you attended the last demo session, so where I was explaining about the basics of data engineering. Okay, so of course we'll go through that again, but just I want to highlight. I want to check like who are all attended the last demo session. All right, so before I get into the things, just would like to understand. So, is there anyone who did not attend the last session? I mean to say the demo session. Everyone attended?
Hi, my name is Deepthi, and I did not attend the demo session, but I have the recording for it. I will take a look at that today.
That's great, Dipti. Yeah, thanks. All right. So let's start and get into the things. So yeah, so every one of you will be getting recording. But yeah, anyway, whatever I explained in the previous session, I'll try to cover that in this week, because I was just giving introduction of the data engineering, what exact data engineering is all about and all. Right? All right. So today what we do is, so we will get into some of the important component or concept called data warehouse and try to understand what exactly it is all about and what are the various component of data warehouse and how it is got evolved. Okay, so before I shared PPT, so let's talk about the data and the properties and how the data got evolved. Okay, so last time I think already asked this question. So what is data actually? So you know what is data? The people who joined just today, can anyone explain what is data?
Data which has some meaning for that one, so it has some value or
Yes. So
gives you
data
some
is,
information. Yeah.
yes,
Mhm.
data is some information which has some properties or which can be measured, okay, which can be evaluated, which can be analyzed. Any information which can be analyzed is a data, right? So in day-to-day life, we do generate lot of data, as I mentioned in the demo session. Okay, so say suppose like before the data got evolved, or sorry, before the software got evolved, what happened? What used to happen? Everyone used to uh, keep the data, okay, over the books. Okay, I mean to say the manual books. So even like a 30-40 years back or 30 years back, everything used to be manual, including the banking transaction also. If you ask your parents or like your grandfather, so they used to perform all the transactions in the manual itself. Okay, even if you take a what do you call this train ticket also, and even if you go to the bank also, everything used to be manual, and even there is nothing called a debit card, so you need to go and withdraw the money manually by filling up the form, and everything used to be manual. Okay, still the data used to be managed, right? So earlier everything was data manual, and before that also there was nothing called a kind of a database terminology. Okay, so everything just was data being handled in the various ways like books and some of the oral things. Okay, oral form they used to maintain. Okay, and everything used to be books. Of course, even if you go to your schools and the colleges, the regular schools, the private schools also, the big education institutes also, they used to maintain in the data. But over the period of time, when the software evolved, then the kind of a worksheets, sorry, the Excel came into the picture and some database came into the picture. So initially they used to like data in the files. Okay, they used to record the files. Then over the period of time, when the data got increased, okay, they thought, okay, there should be a separate mechanism to store the data. Okay, then the concept of database evolved. So database, what is database? What is database? Do you know any database? Any one of you can tell me any database which you come across?
If anything, storage of all that information, right? Oracle or anything. Yeah.
Right,
Postgres or
right.
yeah.
Yes, yes.
SQL Server.
Yeah.
Sorry, Deepti, can you come again?
SQL Server.
Yeah, SQL Server, SQL Server, very good. Anyone else? Can anyone tell me what are the database? What are the databases that you have heard of? like SQL Server,
Teradata.
Oracle,
Teradata.
Teradata, right? Okay, Postgres, one of you were telling me, Cosmos DB. So these are all the various databases which are provisioned to store the various types of the data. But in general, if I talk about database is a collection of information which stores the data in the two-dimensional format. Okay, usually the data will be stored in the two-dimensional format. So what is the two-dimensional format? What does it mean when I say two-dimensional format? What does it mean?
Rows
What
and
does it
columns. Basically,
rows and
rows and
columns?
columns.
So
Yeah.
let me draw something. Just trying to check. So if I see that, say suppose there is a data related to a kind of a student, say suppose the same session. So what I'll do? We'll store the data in the two-dimensional format. So what is that? Student ID, student name. What happened to your my mouse? Okay. Student name and marks. Okay. So ID, name, marks. So 1, 2, looks like there is some issue here. A and B, 1 and 2. So the data being organized in the two-dimensional format, which is a data. Okay. So usually the database will be having the data in the two-dimensional format, rows and columns. Okay. So that's how the data will be stored. Just to give me a minute, I'm getting one important call. Sorry for that. Right. So the data being stored in the two-dimensional format. So over the period of time, what happened? The data used to be stored, and the data used to be everything used to be like two-dimensional format. The data being organized very well, so there are no issues. Everything used to be go smoothly. But if you see over the period of time, slowly the data what used to happen? The data slowly got emerged and the data was multifolded. That means, say, suppose earlier what happened? Only the banks were banking sector was having the digitalization. But over the period of time, what happened? The banking got digitalized, and the train transport got digitalized, the schools got digitalized, even the supermarket in your home got digitalized, everything got digitalized. So this is how over the period of time everything got digitalized. Then there is a need of uh, more and more data storage required. Okay, there is a need of more and more storage data required. Now that time, let us see what happened. Yeah. Now, if you see here, the database came into the picture. The database came into the picture. Okay, the data being stored. Now if you see the database will have organized all the data. And if you see like 25-30 years back, so there used to be roles called database developer, who actually develops the data. I mean to say, who develops the table, who creates the procedures, who writes the data, everything used to be handled by the database developer. Okay, now all the application used to have front end and back end, right? So this is a backend, that is a database, and this is a UI. Say suppose if you go to the bank and you perform transactions, what happens? The transactions will be recorded in the database. And what are the transaction being used, that will be returned back to the UI. Okay, so this is how used to happen. Now at the end of the day or end of the year or end of the month, say suppose the manager or top management want to see the performance of the data. So what they will do? They will write some SQL queries, SQL queries on top of the data. They will try to find out what exactly is happening. Okay, how many transactions happened in a day, how many deposits we got, okay, and how many new customers joined, and what are the various products got the customers, okay, which branch is getting more deposits, which branch is getting more and more cash inflow. So these all used to be fire the queries on top of this database, this backend database, okay, and do everything, right, isn't it? So if you go to this one, this is called database. Okay, this is the front end and back end. So everything is to be performed. But over the period of time, if you see the transactions and this, so what happens initially, say suppose it has like 1,000 transactions, say suppose initial days of the bank. Now then it will be 2000, say suppose. Over the period of time, what happens? 1000, 2000, everything will be like a millions of rows. Okay. Now the same database is being used for your adding the transactions, recording the transaction, and same database is being used for the reporting generation. Both the things happening on the same database. Okay, both the things are happening on the same database. So what happens if you are using this one? Suppose if you are a say suppose you are a non-IT guy, or you don't know anything about on the data or database, suppose, okay, what happens when I use the same component for multiple usages? What happens?
Performance decreases.
Performance decreases, because say suppose I'm adding some table, I'm data into one table, and same table I'm retrieved into the query. So what happens over the period of time with 1,000 rows and all, it's okay. But when it goes to millions of transaction, there will be a performance degradation. Even if you write some queries to summary to get the summary of the data, there also you will find the issue. Okay, so initially which used to take like 1 minute, 2 minutes, it might take like 5 minutes, 10 minutes, which is a performance issue. Okay, then slowly the people realize there should be a separate mechanism to find out or to give a separate database for the reporting. Okay, so what happened? As the data got increased, when the data was normal, then the database concept came, then the reporting was there. But when the data got increased more and more, then the people realized there should be a separate mechanism for the reporting purpose. That's where the data warehouse came into the picture. If you see like 25 years back, 20 years back, there was a boom of data warehouse. Everyone used to learn like the way now data engineering and the AI ML people are learning. So at that time, everyone used to learn data warehouse concept. Okay, that is what data warehouse.
Why was the data warehouse that popular at that time?
Yeah, I will tell you. Now, as I mentioned, when the digitalization came into the picture, more and more industries got getting data. Isn't it? More and more industries were getting data and more data. Say suppose earlier, like how many of us are having the bank accounts? Very less, right? But over the period of time, if you see like crores of transactions are happening, crores of customers are in the various banks. So what happens? Obviously, the data was increased. Say suppose the data was X. Okay, earlier, like after the over the period of time, it became a 2x or 5x. So the data got multifolded. So then there was a need of data warehouse came to the picture. The same database, whatever we are using, we were using, it might not be useful to perform even the further reporting as well. Then the concept of data warehouse came into the picture. Then people started using the data warehouse, where the summary of all the data being recorded are stored separate in the data warehouse. So the top management or the data analyst doesn't need to get into the database, the original database, for performing the reporting. Okay, so that's how every company started going to the data warehouse. Then the data warehouse technology became very popular because of the data, and then the concept of ETL developer, data warehouse developer, BI developer. So these are all roles came into the picture. If you see 2000 between 2002, 2010 or 12 also. Okay, everyone started learning data warehouse. Every company started recruiting heavily because there were more and more projects around the data warehouse, because people realized there should be a separate mechanism for the reporting purpose. Okay, so that's how data warehouse came into the picture. Now, if you see earlier, the people who use it to store the data is called like a bookkeeper, shop bookkeeper. They use it to call, isn't it? I mean to say in the manual system. Okay, then when the database came into the picture, then the database developer role become emerged, and even the business analyst reporting developer became emerged. Now when the data was increasing a lot and lot, the data warehouse came into the picture. Then when the data warehouse came into the picture, then the data warehouse developer came into the picture, BA developer, ETL developer, and all. We'll see what are those actually. So over the period of time, if you see, as the data was increasing, then the new concept or the new technology came into the picture. When the new technology came into the picture, then the new roles are being evolved in the software industry. Now, after a certain period of time, if you see the last 10 to 12 years, then the concept of cloud came into the picture. Then the internet revolution came into the picture. So at the time, what happens? More and more got into the internet, what is it, digitalized. Okay, and internet revolution, thanks to internet revolution and mobile revolution, more and more data started came to the picture because of all the cloud environments. Okay, as the data was increased a lot and lot, then the people realized, okay, there should be a separate mechanism to process the data within the cloud. Okay, with the cloud, then the traditional data warehouse system might not be sorry, during this time, data warehouse came into the picture. Again, data got devolved. Then the big data came into the picture. Okay, big data concept came into the picture. Okay, big data. So in the big data, what used to happen? The same thing, but the data was more and more. Then the concept of big data came into the picture. The concept of MPP came into the picture. I mean to say, processing the data in the parallel. So then if you see like 10, 15 years back after data housing, so everyone used to be big data developers, Spark, Hadoop, so those came into the picture. But when the cloud came into the picture, then people realized there should be a separate mechanism to process the data in the cloud. Okay, then the latest thing, like if you see like 7, 8 years back when the cloud got emerged, then the concept of data engineering came into the picture. Then you don't see data warehouse developer, big data developer roles anymore. If you see last 4 or 5 years, like those got kind of completely faded away, and you see all the roles around the data engineering. Okay, now evolution is happening this way, like as you see more and more data into the system, more and more industries are getting digitalized. You see more and more data technologies are evolving, more and more the technology related jobs are also getting evolved. Okay, so that's how you need to understand the pattern. Now data engineering, but like if you see a decade after, more and more data was increasing, we don't know what kind of data related job opportunities would evolve. But if I summarize this in a nutshell, if you see, always there is a data, there is nothing called issue related to the data. I mean to say, always, as long as the data is there, okay, as long as you believe or trust in the data, data related jobs would be evolved, and there is no issue related to the job opportunities for the data related things. Okay, that you need to understand. Now, you know what is database. Of course, we'll be having a separate set of sessions for the database, whoever is new to the database. Now, let us talk about the database we spoke about, what exact database is all about. And database will be having DDL, DML concepts and all, which we'll go through in a separate sessions. But now, let's talk about what exact data warehouse actually. So why you need to understand data warehouse? Because in the data engineering, whenever you get into the data, okay, the final goal is to get all the data into a final layer, as I mentioned, for the reporting purpose. That's called data warehouse. Okay, we'll try to understand what exactly the data warehouse is all about. So what exactly the data warehouse is all about? So as I mentioned earlier, so there will be a UI, there will be a database, and to for the reporting purpose, we'll be having a separate database called a data warehouse. Okay, data warehouse. Oh, sorry. Data warehouse and the database. Right? So database. So the data being pumped from the database to data warehouse. Okay, that's what I told, right? So this is how the data being organized. And let us talk about what exact data warehouse. I keep using the terminology called data warehouse, and I keep saying the point that for the reporting purpose we use that. Then what exactly the data warehouse is all about? So data warehouse is nothing but a decision support database, that means specially used to get the decisions, that is maintained separately from the organization database. Okay, by processing and providing a solid platform for consolidated historical data analysis. That means whatever the data we are getting from this database, a separate database will be maintained, okay, which will be having all the consolidated information and which will be used for the reporting purpose. So this is the database, say suppose, and this is the data warehouse. And say suppose it has like suppose 100 tables. Say suppose I'm giving example, but it might have only 10 tables because it will have the consolidated information. That means whatever is needed for the reporting purpose, only that information will be stored separately into the data warehouse. Okay, so basically it's also called DSS, that is the reason, decision supporting system, right? So that's called the database. Now WH Enman, so who is kind of a master in the data warehouse, who kind of started the what do you call the concept of data warehouse. He says that, hey, data warehouse is nothing but which has the data, and the data would be a subject oriented, integrated, time variant, and non volatile. He says that the properties of the data is different entirely between the database and data warehouse, because database data will be subject oriented. Subject oriented in the sense, whenever you analyze the data, how do you analyze the data? You analyze based on the subject. That means how many customers are there. Customer is a subject. And which country, which location got more transaction, then the location is a subject. Okay, and say suppose which department got more profit, then the department is a subject. So whenever you are storing the data in the data warehouse, the data would be subject oriented, integrated. Why I'm using, why this term is being used? Suppose sometime the organization might have more than one database. Okay, and also depends on multiple databases, multiple schemas, the data will be scattered. So what we will do, we will kind of integrate the data. Okay, integrate the data into a single database. So integrated, time variant. Time variant in the sense everything will be tagged with a time. So as I mentioned, in 2020, what was the revenue of Apollo Hospital? And from yesterday to today, how many more heart-related patients came to hospital, visited hospital? Okay, and from last year to this year, how many Swiggy customers ordered biryani? Okay, so these are all time-related data. Non-volatile. What is volatile meaning? What is the meaning of volatile in general sense? In general English, what is non-volatile?
Something which changes dynamics fastly.
Yeah, fast. Very good. So volatile means which keeps changing. But if you say non-volatile, which doesn't change, because once the data gets stored in the data warehouse, which won't change, we just keep adding the data and get the summary of the data. That is the reason it's called non-volatile. So basically, data warehouse will be having subject-oriented, integrated, time variant, and non-volatile data. Okay, so that it helps the management for the decision making process. Okay, so that's called data warehouse. Now, so of course data warehousing is all about processing the data and constructing the data warehouse. Okay, and if I summarize this, so the data will be multiple sources, as I mentioned. It is integrated and stored into the warehouse, and business analyst or reporting developer performs the queries or fire the queries on the top of the warehouse and do the analysis on top of this data. Okay, so that is all about the data warehouse. Now, this database is there, okay, and the data warehouse is there. 1 minute.
Can I ask something? Yeah.
Yeah, please, please.
Okay, so warehouse is basically a source of data coming from different sources,
Yes,
different kind of data, right? It can be Oracle, Postgres, and it can be coming from your MongoDB or somewhere, and
yes,
so
you're right.
different source
You're
of data, different types of data that come into warehouse. Okay,
yes, you're right. You're right. You're
okay.
right. Now, there is warehouse. So, because ultimately, if you go to data engineering or any related project, the original summary, sorry, the actual goal would be to store the data into one platform for to help the analysis. That's where the warehouse came to picture. So that is the reason before we get into data engineering, you need to understand the warehouse concept. That is the reason I added this session. Okay. Now this is a warehouse, and warehouse will be having information. So because this having the data and it's helping the data, what do you call the decision making? It's also called DSS. 1 second. It's called DSS. And it's also called data warehouse, decision support system, data warehouse. Now this day-to-day transactions happens in the backend, right? Every database, every application will be having a backend where different transactions comes into the picture. Okay, addition, deletion, modification of the data, all the transactions. So that is the reason this backend databases are called OLTP, online transaction processing. Okay, OLTP, online transaction processing, the backend databases are called. Now this database, the separate database which is helping for the decision support system, is called OLAP, online analytical processing. Okay, so data warehouse also called as OLAP. Data warehouse, DSS, OLAP. All these processes are tightly, all are same, and this is being referred with the various terminology. And this backend database is called also backend database, or it's called OLTP, where the transactions happens. Okay, so ultimately the goal of a data warehouse developer was to construct a data warehouse, or to construct a OLAP format, or to construct a DSS based on the data of OLTP. Okay, so that's about the data warehousing. And if I summarize in a simple format, basically if I check these two different things that I've added to summarize, OLTP, day to day transactions happens at the backend database. Basically it's to run the business. OLTP used to run the business. OLTP is to run the business, and whereas data warehouse helps to optimize the business. Why data warehouse helps to optimize the business? Why I used this slide? How this helps to optimize the business?
So
We
more
can
business
know
activity,
like
right?
gaps in the business.
Sorry.
We can understand where is the gaps in the business. Like, for example, the seasonal. In particular season, suppose in summer we have like AC sales are more. When come to the winter, the sales won't be that much. Like, or else like regional wise or seasonal wise, the demand will be changed. So based upon that, they arrange the stocks accordingly.
Exactly. They optimize the business means they will take the decisions based on the data warehouse data. So once you analyze the data into the data warehouse, then you just don't publish the report and leave it there. No. Apart from that, you take the decision based on the data. Say suppose this year I was giving same I'll give the same example. Swiggy is not performing well much. Okay. The biryani orders used to be like 100 in a day. Suddenly it went down to 10. Okay, nobody bothered about ordering something from the outside. So what happened? Suddenly they will add some flashy discount sale. Okay, buy one get one. Any biryani 49 rupees, any burger 49 rupees. What happens? You will tend to order that. And suppose suddenly the Samsung ACs, the same example, are not being sold that much just before in the non-season. What they'll do? So they'll add some 20% discount, 10% discount, and even in the summer also to spike their order, their spike sales, they will give some discounts like 1 year warranty, 2 year warranty, or they will try to give like free installation, these kind of things. isn't it? So based on the data, you will analyze how it is performing. Okay, what kind of decision you make, then you will try to optimize the business. So that is the reason OLTP is used to run the business. The data warehouse helps to optimize the business. Okay, by taking the better decision. Okay,
Yeah.
so that helps, like the summary, that the way you are telling, like who are my customers, okay, which customers are likely to the completion, okay, which products are getting business revenue, okay, what is the most distribution channel, okay, what impact will be having if I do some services or extra a discount sale. So these are all usually producer wants to know, that being done, that being helped by the data warehouse. Okay, so that's how data warehouse helps a lot in getting the data, right?
Can I add something there, or is it?
Yeah, yeah, please do that.
Okay, so if we go back, right? So that old TP is your transaction one, so which is basically any fast transactions, right? Anything that is happening immediately and need immediate response, that is the one. OLAP is basically you're optimizing. When you're saying optimizing, you're trying to figure it out. Um, so my understanding, correct me if I'm wrong. So someone wants to order something on Blinkit or something, that will go
Yes,
to OLTP
OLTP.
to, yeah, because they were ordering something and they need immediate one, and then the tracking can happen and everything, right? And the OLAP, eventually, if the end of the day, if someone wants to pay the what they call the delivery guy, how many deliveries he made and everything. So that data will come to all your OLAP, and where they will do the summary of all the deliveries done, how much time it take, and all of those things, and then he can do the payment, right? Or something like that.
You're right. You're right. So the day-to-day
Okay.
transactions happens in the
Mhm.
OLTP and the summaries of the data being retrieved by the data warehouse. If you give the same example, say suppose if you are going to bank and you're performing
Mhm.
train transaction, or if you are going to ATM, okay, or you're swiping your credit card, all the day-to-day details will be stored in the OLTP. Okay, but at the end of the day, okay, what happens is
Mhm.
all data will be summarized and stored in the data warehouse. End of the day, or for every 1 hour or every 5 minutes, depending upon the what do you call, depending upon the schedule, depending upon the business requirement, the data will be summarized and stored into the data warehouse. Then the decision will be taken. Okay, today how many new customers joined? How many?
Mhm.
How much total fixed deposits we got into the bank? Okay, how many credit
Yeah.
cards got issued in total? Okay, and
Yeah.
if you are offering any new services, uh, how was the impact of the services? Okay, because from the compared to yesterday to today. Okay, so these are all
Okay. Yeah.
summaries will be stored in the data warehouse. Okay,
So in the current environment, what are the different warehouses, data warehouses, products we have?
yeah, I'll talk about it. Okay,
Okay.
now this is the OLTP. This is the OLAP, as I mentioned. Okay. Now, over the period of time, when the data was increasing, as I told, so between 2000 to 2010, then there was an era of data warehouse. Everyone used to learn. If you ask your siblings or your seniors, everyone used to learn data warehouse and used to get fancy jobs because that was the high demand for the data warehouse. Now, okay. So before getting to the differences, as I was saying, there were so many databases, like it was Oracle, okay, SQL Server, isn't it? Oracle, SQL Server, Teradata, all the databases used to be there. But, okay, earlier, when the concept of data warehouse not much evolved, the same databases they were using. Okay, the same database. That means they used to construct the data warehouse. They used to construct the data warehouse within the SQL Server only. They used to construct the data warehouse within the Oracle only. Okay, but they were not giving much performance whenever you fire the query. Okay, because of the data volume, because of the various platform, the data was not efficient enough to store the data in a single single database. Okay, then the separate technologies evolved for the data warehouse. Then the best example was the, what do you call, the Snowflake. Snowflake is specially designed to store the data warehouse. And also, if you talk about one more data warehouse, Synapse Analytics. In the Synapse Analytics, we have the data warehouse capability, which is called dedicated SQL pool. Dedicated SQL pool in the Synapse and the Snowflake. So these are all specially designed to store the data warehouse data. Okay, now yeah, if I answer your question, yeah, so Snowflake, the dedicated SQL pool which now no longer being used for now, of course. But these are the primarily data warehousing databases which we had. Okay. Now, why I need to go for a separate database then? Why I can't use the separate the same database for storing the data? What is the different format of data? How different the data would be between what is the difference would be between the OLTP and OLAP? How the data would be different? That you need to find out. So that's how that is the reason I added this slide to understand the difference between OLAP and OLTP. That means the data warehouse and the regular database. Now, if I summarize whatever I spoke in the last 15-20 minutes, OLAP is used for the data analysis, as I mentioned. Okay, whatever the data that you have, that will be used for the data analysis, like how many banks customers came into picture in the Apollo hospital, how many new patients visited, okay, how many heart patients happened, what was the revenue, okay, and in the Swiggy, if you suppose Blinkit, like someone was asking Blinkit, like how many new products got sold, what was the total revenue of for a month for a particular location. So these are all analysis takes place in the OLAP. Then the OLTP, what happens is to manage large number of online transactions. Whatever the transactions happens in the day to day, that will be managed in the OLTP. Okay, OLTP, the data will be stored. And of course, it uses data warehouse database. Okay, it uses a traditional DBMS. Okay, it uses a traditional database management system, DB, and it uses database. Of course, as I mentioned, the decade back, okay, there was no separate data warehouse databases. The whatever the OLTP are being used, the same database is used. But over the period of time, new set of technologies evolved for this purpose as well. And here there is some mismatch I need to gain your attraction. OLTP used for this purpose. It manages all inserts, updates, and deletes. Say suppose you're depositing something. So what happens? It will be updated, and your customer want to get out. Close this transaction. Then the delete will be happen. Suppose a new customer join, then the insert will happen. Okay. So usually in OLTP, what happens? Inserts, updates, deletes happens. And in the OLAP, there won't be any transactions happens. You just keep adding the data. That is the reason it's used mainly for data reading and data analytics. Okay. And one more important thing, response time. Because every day so many transactions happen, so much of a huge amount of the transactions happens. Usually the response time will be a bit slow in the OLAP, but OLTP. But in the OLAP, the time, not milliseconds, but you can say seconds. That means usually the response is very quick compared to OLTP. Why? Because say suppose if you have the 10 transactions in the 10 records in a what do you call in the OLTP. I don't need to add all the transactions. Suppose you have so many customers. Say suppose Deepti, Chandra, Bhargav, Nanda, Navya. So these are all the various customers in my bank. Okay. When I try to store the data in the OLAP, in the data warehousing, I don't need to store about all these customers. Okay. Just I will say for a particular day, how many total customers are there, how much transactions happened for this particular branch. That kind of summary I will store in the data in the OLAP, so that I don't need to fire again group by queries, aggregation queries. Directly I can pull the data from the OLAP. So that is the reason, as it has the aggregation data, the response will be good. And of course, the normalization. The data usually from the OLTP normalized. I'll talk about normalized in a separate session. Normalization in the sense, whenever you are storing the data in a database, you will try to break this into multiple tables so that you can implement the transactions easily. But when you go for the OLAP, usually the data will be denormalized. That means one or two tables are there, you will try to combine and store the data into the OLAP. So that is the reason you will gain the performance advantage whenever you file the query. Okay. So why you need to understand all these things? Why I don't jump? Why can't I jump directly into the data engineering? Because as a data engineer, you are responsible. One of the primary responsibilities is to load the data into data warehouse. Okay, even though you're not a data warehouse, for the namesake, you're not a data warehouse developer, but at the end of the day, you're going to store sometimes, not always, but most of the cases, you might need to tend to store the data into data warehouse. That is the reason you need to understand the data warehouse basics. If you go for a data engineering interview, they might ask, hey, what is OLAP? What is OLTP? Why OLAP is different from OLTP? Why you need to store the data into data warehouse? These are all questions being asked whenever you go for interview as well. Okay. Now, I added a couple of, I was saying the data will be extracted and loaded the data into data warehouse. Isn't it? I was keep saying this term. Then how this data loading takes place? Who does this? Okay. What are the various things that comes into the picture when I say loading the data into warehouse? I need to extract this data and then load this data. Okay. Then the concept of ETL comes into the picture. Okay, the concept of ETL comes into the picture. So what is ETL? It's all about storing the data into the data warehouse. Okay, so this is all about ETL is all about extracting the data from the OLTP and loading the data into OLAP is called ETL. This is also one of the terminology you need to use. So ETL is, you can say, a subset of a data engineering. Okay, within the data engineering, you will be performing ETL or ELT, which I'll talk about in the next slide. So ETL is nothing but extract, transform, and load the data. ETL. So why this term? Because you are extracting the data from this OLTP, you're transforming the data so that the data will be organized well in the data warehouse. Then finally, you are going to load the data into data warehouse. Okay, so ETL talks about all about extracting the data from multiple sources, which is OLTP, and transform so that it is ready for the analysis, and load the data into OLAP, which will be used for the analysis. Okay, so this is about the ETL. Okay, so what exactly ETL does? ETL provides a foundation for the data analytics and machine learning workloads. Even the ETL is the concept through which you can extract the data and prepare the data for the machine learning as well or data analytics. So what actually happens in the ETL? You will cleanse the data and organize the data. Because say suppose in the day-to-day transaction, there might be different kind of data, as I mentioned. Say suppose there's a one, two different databases are there. So what happens? Sometimes the data will be duplicate. Okay, by mistake, what happens? The data will be duplicated. Some data might have junk data. Some data might have what you call invalid characters. Some data might be not relevant for the data warehousing capability. All this transformation will be done from the ETL process. Okay, say suppose there is some data which is duplicate. So what I'll do, I'll try to remove the duplicate. Suppose there is XYZ, there is some junk data is there. I will try to remove this data. Okay, sometimes the data is between 1970 data is there, but I want only after 1990. I will filter this data. Okay, suppose there are some columns X and Y, and I need to compute Z. Then I will try to compute this data. Okay, transform the data. So whatever the data updation, data transformation, data quality, all the series of transactions I will do with the help of the ETL and load the data into data warehouse. Okay, so this is called a ETL. So ETL basically it cleanses the data and organizes the data so that the data will be ready based on the business need. Okay, so that's about the ETL if I summarize. And of course, if I summarize, it extracts the data from legacy system, it cleans the data to improve data quality and load the data into the target database. That's called ETL. So that's how sometimes you use it to see ETL developer, okay, who loads the data into data warehousing. So for this ETL, there are several tools are there. Does anyone heard about ETL or ETL tool anytime?
Yeah, Informatica, Talent, and all of those things, right? Yeah.
You're right. So there were separate set of tools for there. Like as I was saying, in between 2000 and 2010, there was the era of data warehousing jobs, right? Everyone used to learn these ETL tools only because through ETL tool only you can perform this data loading and build the data warehouses. So Informatica, Tailend, SSIS, Data Stage, Abnisho, SAP BI, SAP BIW, and even Oracle as Oracle BW. Yeah. So various data warehouse, sorry, various ETL tools are present to extract the data or to load the data from the data warehouse to data. Now, of course, as the cloud came into the picture, data engineering came into the picture, like the traditional ETL tools got faded away. Everything is being used from the modern data technologies, which we will talk about in the next few days, few weeks. Now, so that is the reason Informatica jobs and those jobs you are not hearing much the way you were hearing earlier, a decade back. But still, what happened? Informatica also became clever and they integrated their tool to the cloud so that for the modern data engineering also the people can use the data Informatica. Okay, so many changes which we'll talk about it. Right now, I spoke about ETL, extract, transform, and load. Okay, but in the modern data engineering, sorry, in the modern world, it's not about transforming and loading, because when you say ETL, what happens? You're transforming, you're holding the data, transforming and loading the data. What happens when the data is huge? There will be a performance bottleneck, because in the transit, you're trying to transform the data. Okay, over the period of time when the cloud became more cloud revolution came into the picture, then the traditional ETL gone, then the concept of ELT came into the picture. So you don't transform while loading. First you load somewhere, then you do transformation based on your requirement, so that always there will be a copy of your source system and you do the transformation based on your requirement, and the data always resides with you, so that you don't need to extract each and every time, and you already have a snapshot of the original data, so that, and also you have the data with you only. It will be easy for you guys to transform the data based on your requirement. Okay, so that is the reason all the modern data engineering practices, they do use the concept of ELT. Okay, now let us talk about what exactly ETL and ETL, then why the difference is. ELT is the method of looking at the data, approach to data movement. Instead of transforming the data before it is written, ELT allows the target system to do the transformation, so that the data is first copied into the target, then you do the transformation. Right now, you might face a question: what is the difference between ETL and ELT? Okay, so just added few points, but if I summarize this, ETL usually will be used when the data volume is very less. ELT is used when you have the huge amount of the data. So in the ETL, what happens? The data is transferred to ETL server. If I say Informatica server, the data will be used and the data will be loaded back to the database. That is the reason you need high network bandwidth. When you say ELT, you can store the data into the DB and you can transfer the data there itself. So transformations happens in the ETL server, the transformation happens in the target database. So when you have a huge amount of data, usually you will be using ELT. So that is the reason all the modern data application uses the concept of ELT only, not ETL. Okay. And when you want to just transfer the data, when you have small amount of the data, then you will be using the ETL. Okay, time maintenance, low maintenance, because already the data is available for you. And if you say ETL, every time you need to extract the data and transform, so there will be a extra overhead on the system to get the data, right? So this is the basic difference between the ETL and ELT. There is nothing called separate ELT tools, the same set of tools, but just that the approach will be different when you extract the data.
So it's just the process, is it? Tools are
It's just
same. It
yeah,
could be
tools are same. It's just a process. Say suppose if I use what do you call this? Let me tell, data factory. Within the data factory, I'll use the ADF. Sorry, in the data factory, I will use the ETL and ELT also. Suppose Databricks, I can use the
uh-huh.
Databricks for ELT and ETL also. It's just a process, or the system, or the way that you're processing the data is different. That's it. Just the terminology or the system. There's nothing called ETL tools or ELT tools.
Okay. Okay.
Yeah. So before I get into the system or move further, does anyone has any question?
So the data warehouse,
What
you
are
said
the
it's Snowflake, right? One warehouse is Snowflake. And
Yes.
ETL, ELT tools are same. So Informatica, Talent, anything could be the tool, right?
Yes. Yes. You're right. You're right.
Okay.
what are the content we are going to cover in this and duration?
Duration is 2 months. I think content being shared with you, but if not, they will share it with you today, maybe. But the content usually, if I take if I talk about high level, we'll be covering as cloud fundamentals. Okay, then the Azure storage and data factory, data bricks, and fabric, and so one or some sessions on the Synapse as well.
Fabric we are going to cover whole or like overview?
Overview, and also we will talk about how the fabric notebooks would be covered, fabric data factory, and creating the agents as well. Even we are covering agents as well.
Okay. And Databricks, Azure Data Factory, we are covering whole, like
Yes.
those things.
Whole in the
I mean,
sense whole. Yeah.
yeah, I mean Databricks with SQL or Python?
Both.
Databricks.
Both SQL and Python, both PySpark and SQL, Spark SQL.
Sure, sure.
Yeah. So there is a detailed content is available. So you will get from the management today. All
Sure,
right.
sure.
Yeah.
Thank
Yeah.
you.
Yeah. So this is about the data warehouse and ETL and all. So I would like to talk about the Starflex schema, how the schema would be, how the facts would be, but not today. I want to pause it so that you can digest the things, whatever I spoke about, and we'll speak about what exactly the data looks like in the data warehouse, why it is called OLAP. Okay, how different the data will be organized. So these things we will try to finish, and then we will move to cloud basics in the next session. All right. Okay. So that's what I want to talk about today. And I will park last few minutes for the Q&A sessions before I stop recording. Okay. But yeah, let me stop recording. And if you have any questions, you can ask me. Feel free to ask. Or let the recording would be, let the recording stay on, and if anyone has any questions regarding the content or the whatever we did speak today, and if you feel that I'm going a bit faster, try to push me back. And if you have any questions, you can ask me immediately, or there is something called chat in your Zoom. You can post your questions, that will be redirected visible only to me. Okay, that also you can do. You can post your questions in the chat, or you can ask immediately, or in the next
I
session also you
can.
can ask.
Okay, so you will cover. I'm looking at your course content. So Azure Data Factory, Azure Data Bricks,
Mhm.
right? That's what you
Yes,
cover, and
yes.
Fabric, right? I think those are the ones.
You're right, right. Yes.
Okay,
So
analytics is gonna be Synapse. Okay.
yeah, yeah. So see here, I'll talk about a couple of minutes on that. See, earlier the major integration tool, not integration tool, unified tool was a unified technology was Synapse from Microsoft. Okay, so Microsoft used it to develop more and more projects on the Synapse Analytics, which is a combination of multiple tools like Data Factory. I mean to say pipelines, called pipelines, dedicated SQL pool, serverless pool. These are all concepts were there under the Synapse. So everything used to be done under one radar, that's called, which we'll talk about, of course. But over the period of time, so as there were some upgradations needed, then they came with the concept of Fabric, okay, which you can say upgraded version of Synapse. So over the period of time, what happened? All the projects whichever are running are already implemented in the Synapse. They slowly migrated to Fabric. Now, if you see in the last 1 or 2 years, 1 year or so, you see more and more projects around the Fabric. In the next few years also, you will see more and more projects around the Fabric. So that is the reason I have added explicitly Fabric by reducing the content on the synapse. Make sense?
Yes, yes, yeah. So can you talk a little bit about like what is difference between data factory and Databricks?
Yeah. So data factory is a kind of an ingestion tool. Okay. So where exactly you're going to getting the connecting to multiple sources and load the data. Okay. And whereas Databricks, so which is developed on the Spark platform, okay, massive parallel processing MPP architecture, which will be basically used to process your data. Okay. Say suppose I have two steps. One, I want to pick the data, then I want to process the data. Then I will use ADF to pick up the data. Then I will use Databricks to process the data. Okay. Even you can transform the data using ADF also, which I will talk about it. But ADF might not be suitable if there is a large amount of the data. Then you will use the Databricks for processing the data, like transformations, validations, data quality checks. So these are all will be used in the Databricks.
Databricks, okay.
Yeah.
But is this the Databricks the same as like whatever the product outside, like the Databricks?
What does it mean? I did not get that question.
Like Informatica, there is a Informatica and Snowflake, there is a company called Databricks, right? So
Yeah,
is
yes.
that same thing as this Azure Databricks or with different ones?
Oh, okay. So Databricks is an entity, a separate company, and the product has developed on top of Spark. Okay. Then
On top
Azure
of,
or
sorry,
Spark platform.
Spark. Okay, okay.
Spark, yeah. So what Microsoft did is Microsoft did invest some of the thing, and they made it as their one of the offering. It's not their own Microsoft product, but you can say it's kind of a some joint product from the Microsoft itself. So that is the reason Azure Databricks. And what happened slowly? So AWS, I mean to say Amazon also started offering the Databricks. That is the AWS Databricks. Okay, but usually Databricks is same wherever you go, the same set of operations, same things would be there. And Microsoft integrated in this marketplace where you can create the Databricks from the Microsoft itself and you can start working on it. And without these also, Databricks can be an independent product which you can use and perform your or implement your applications.
Okay. And what is the difference, the pipeline wise, right? I think you saw pipeline something to do with Data Factory.
Uh-huh.
Okay. What is the difference between that and the one which we have like Kafka or something else?
All are same, depends upon the data. Okay, depends upon the data. Some data, both the usually you'll be having two types of the data. Okay, one is the batch data, one the real time data. Batch data in the sense static. That means say suppose if you are performing these transactions at the end of the day, I will try to summarize the data and store it data. It's called a batch data, which comes in a certain intervals. Okay, then you have also called real time data. Real time data in the sense which keeps changing or not keep changing, keep generating. Say suppose your electricity data keeps generating. So either or your mobile data, your mobile application, the mobile data will be keep generating a lot of data. You need to analyze very quickly. So for such kind of data, you will have separate set of streaming application, streaming processing will be there. Say suppose one of the tool is called Kafka, through which you can get the transaction data, streaming data, and process it. Okay, so whatever the technology that you use, whatever the type of the data you have, ultimately the concept of pipeline is same. Pipeline is a generic terminology which you will build to ingest, store, and process the data. Got it?
Yes, yeah.
All right, I'll stop recording, and if you have any offline questions, you can ask as well. Thanks everyone. I hope to see every one of you in the next session. Thank you.
Thank you very much.